So as a matter of fact, much of the sort of content of this paper was already discussed by Glenn in his practitioner panel, right? Especially Mr. Thomas Mackenzie's excellent example of Netflix, right? And the implication that has. Okay, but that's not surprising, right? Because this paper, we've sent around for some time now. Okay, and there's always actually a big difference between the perception by practitioners and by researchers. Researchers say we are overly skeptical. Practitioners say, oh yeah, right, we get that. Okay, and I think that's an interesting difference in perspective which is worth thinking about. Right, this paper is really written more, I think, for the academic community. You will see there's a research agenda there, but given the interest of time, I'm not going to go into that. Okay, oops, now what? Okay, so there is, of course, as we know from this conference, huge interest in big data, right? Apparently, Deloitte is spending $400 million on it, so they say. Okay, PwC is doing pilot studies on 10 audits, that was mentioned in the AAA last year, and so on, right? And I could go on from KPMG and so on. I mean, everybody is doing stuff on big data, and we are dead. All right, now what? Come on. Okay, right, and of course academic researchers are very excited too. All right, they have a special issue in Accounting Horizons. Okay, and recently the AAA had this conference, Accounting is Big Data, all right, which had 180 attendees. People were turned away at the door, so there's a lot of excitement about this. But we've seen this story before, right? To go back to the example of the 30 years ago audit, all right. For many years, people have been putting forward all manner of new technologies for auditing, all right. Sometimes by the same people who talk about big data, like me and Glenn, all right. We said the same thing about other technologies in the past, all right. And the history of technology as applied to auditing is not very promising, given its, given what we see. Okay, so in this paper we recognize that applying big data to auditing is a challenge. Okay, it requires a very different a paradigm shift. Okay, it requires doing things auditors have not done before or not done well, such as direct access to data, looking at non-financial data, lot of increased technical skills and so on, and a lot of new business acumen. I mean, the kind of mindset required to look at big data is different from doing that of a regular audit. Okay, and the point we wish to, it should be obvious. Just because something adds value to a client in a profit-making enterprise doesn't mean that it adds the same value, right, in an audit environment. Now again, the purpose here is not to say that big data is not going to have a role in auditing, right? Everybody mentioned on this panel earlier, in 10 years the audit will look very different from what it does now, all right? And that for credibility reasons, auditors will have to do the kind of big data analysis that their clients are routinely doing right now, okay? But what we're saying is, let's analyze this, right, and try and understand where this is going to add value and where it doesn't. Okay, and the way we did it was to recognize that big data has actually been in use outside auditing for quite some time now. All right, there's been a large literature and a large discussion in both the research and practitioner community by non-accountants on big data. And so what we've done is to go on and look at that literature and try and learn the lessons from that, so that we as accounting practitioners or audit researchers don't have to reinvent the wheel. Okay, now. Okay, so the objectives are here is to look at the pros and cons, to provide a balanced discussion, recognizing there are cons. Because sometimes, you read this and it's like, oh, this is the greatest thing since sliced bread. But we got to understand that like any technology, it has pluses and minuses. Okay? And then we present a research agenda, which I won't talk about here. Okay, now, whenever we present this, academic researchers say, oh, you are too skeptical, right? One person wrote, does this mean I'll never do auditing, big data research in auditing ever again? Right? So, well, that's really up to you, right? But, skepticism in auditing is not a negative. It is a source of value that we provide. All right? That is what professional skepticism is all about. And what we do is apply skepticism not to denigrate the subject, but to say, look, we've got to identify when it will add value and when it doesn't. Okay? So no, we are not being overly skeptical, right? We are being clear-eyed, I think, about it. Okay? So here's an example of why I think this kind of perspective is necessary, right? This is a famous study that was done, right, of Cyclone Sandy, or Superstorm Sandy that struck the tri-state area of US 4 years ago, okay? And someone did a big data study of tweets, right, to assess where the major storm impact was, okay? And the analysis said most of the damage was in Manhattan, okay? Now, this was wrong. Most of the damage was in New Jersey, but the reason the big data analysis said it was New York, right, was because that's where most of the tweeting came from. All right, in those days, that's where most people who were technically literate were doing tweets, right? So there's an example of the kind of misleading conclusion that big data can provide. So now we gave this as an example in the paper, okay? And a referee said this. All right, this is a straw man argument, right? For example, the discussion concerning Twitter about cyclones is suspect. Wouldn't big data include an analysis of weather maps? Okay? Now, we could respond to this argument in several ways. One we could say is that, you know, that analysts were trying to assess damage impact, not the intensity of the storm, which is why they looked at Twitter data. Right? And also that the people doing this were computer scientists who are much more capable of doing big data analysis than most audit researchers, you know, maybe outside this room, could do. Okay? But that response is pointless, right? Because when the referee is saying this, right, what the referee is doing is, I think, what is properly called magical thinking. All right? The belief that because you say big data, it's like some supernatural power, it includes every data that's relevant to your analysis. Okay? There is no recognition that big data is simply a means towards an end, which means that, like with any other methodology, how well it works depends on the choices you make about what data you analyze and how it is analyzed. Okay? So, as long as people think something like this, right, we are going to have problems in the application of big data. Okay? So no, it doesn't include analysis of weather maps unless you choose to include it. All right? Okay. All right? So, what do we do in this paper? First, we define big data. And again, I'm not going to go into the details because this is discussion most of you have known already. But one thing to recognize is that there is no one definition of big data. There's one website that at the time, maybe it has more now, has 40 different definitions of big data. So I think that tells you something. This is still an emerging new field. All right? So, you know, there is no clear-cut assessment of exactly what this field encompasses and where it's going. So there's all these definitions about, you know, it's, according to Wikipedia, it's a term that's so large and complex that it becomes difficult to process using on-hand data management tools or traditional data processing applications. That's a widely used definition, but of course that's a rather strange definition, right? Because by that argument, Ball and Brown's analysis in 1968 was big data, right? Because they had to come up with their own tools to analyze that hand-collected data, right? So clearly that's not quite what we mean here, all right? There's other definitions, volume, variety, you know, etc. All right? The one we use is the notion that big data is transactions plus interactions with observations. In other words, that it's ever larger sources of data, all right? But other people have other perspectives. For example, some people say, look, the big data we talk about now, it's not really more data because we've always had more data than we can handle. It's the ability to do analysis of that data that's really driving the move towards big data now, and so on, right? But again, the only point to take away from this is that this is still an emerging field, all right? So we need to be aware, be mindful of that before we jump into this, okay? All right? As far as applying it to auditing is concerned, you know, this is a sort of overall thought about it, there is a well-known saying, extraordinary claims require extraordinary evidence. But I think the converse is also true, right? That extraordinary evidence is only necessary if you have extraordinary questions that need answering, all right? And so what we could ask is, what are these extraordinary questions in auditing that we can only address using big data? Because ultimately, if auditors feel that they're getting sufficient answers now with the data they're using, what is their motivation to go towards even bigger data sets beyond that? Okay? Also, be careful when a lot of people say the word big data in auditing context, they don't mean real big data of this vast sort that they're talking about here, going all the way to the end. They really mean using 100% of the data they're using now as opposed to sampling, all right? And that's not just me saying it. I talked to a partner at a big firm that highly advertises they're doing big data, and he was laughing and saying, no, this is nonsense, right? Whatever we may say, what they're really doing is just looking at a lot more structured data, not going into these unstructured data sets that people in computer science get excited about. Okay? Again, that's only one anecdote, but it's just an example of how practitioners have a different perspective. Okay?
Michael?
Okay. We also, you've got to be mindful of the difference between more of the same kind of data that they're already using and different kinds of data. All right? When people talk about big data outside auditing, they really mean more of a different kind of data. But one perspective is that we should go and just look at more of the data we're doing now. So that would lead us, for example, towards continuous assurance. Okay? Right? Now again, there's a lot of pros for using big data, which a lot of people have talked about. We identify some here. But I want to point out some of the cons. As Thomas mentioned earlier, one of the issues is that that businesses can experiment with big data, like Netflix sending you your recommendations, right? But it's quite different for auditors doing that, right? Because even a 1% improvement in a drug efficacy or a marketing campaign is a good profitable investment for a company making profits. It's not clear how you apply that mindset into the compliance world of auditing. Okay? And as Glenn mentioned in the panel, one of the big things that we need to be aware of is that big data facilitates search of patterns and experiments with unexpected correlations, and that's not so easy to apply in an audit setting. All right, so here a well-known big data expert was talking about the changes this will require. To collect and use a lot of data rather than settle for small amounts of samples, to shed our preference for highly curated and pristine data and instead accept messiness, all right, and give up our quest to discover the causes of things in return for accepting correlations, all right, and we don't have time to go through all this, but I would point out that all three of these are in fact very difficult for auditors to do, all right. We had just had a panel on audit data standards, which is on getting access to financial data, right? So now we're talking about getting access to non-financial data, which is 1,000 or 1,000,000 times larger, okay, without knowing exactly how to get it or why we are supposed to be getting it, all right? So collecting data without a need for it, that may make sense for internet companies, but it's hard for an auditor to go to a client and say, give me all your data, but I can't tell you what I'm going to do with it. All right, which strictly speaking is what big data is supposed to do. All right, this idea that we should accept messiness, that we should allow inaccuracies to slip into the data, right? Again, these are not easy things for an auditor to do. All right, and this idea of correlation versus causation, right? That simply learning an association among phenomena and using it to get things done is sufficient. Again, that depends on the context, whether that is a sufficient explanation, reason to do something or not. Okay? How about this? Correlation is enough, we can stop looking for models. All right? We teach, in research we say correlation is not causation, and that we should be careful about correlations. But that is the essence of big data, right? The correlation is all that really matters, and that you experiment to see whether that leads to a useful result or not. Okay? And I don't have time to go through this, but there are examples, right, where initial success in big data has turned out to be flawed. So Google flu trends, which was supposed to be much more accurate than the CDC, well, eventually broke down. Why? Because people started searching on Google for stories on the flu. So then, of course, they're inherently driving up the perception of there is actually flu there, whether there is flu there or not, right? So again, it's not that big data is not valuable. You just got to be very, very careful in how you use it. Okay? All right, so we've got a quick, there is actually a big debate that we should be aware of in the big data community on the role of theory. Do we need theory when we look at big data, or does the numbers speak? Do the numbers speak for themselves? All right, and okay, some people say that if you just ask the right questions, you can just get the right answers without knowing what you're looking for. But others are saying, look, the dirty secret of big data is that no algorithm can tell you what's significant or what it means. Data then becomes another problem for you to solve. All right, again, it's not that, what we're saying is there is a debate on this within the scientific community on big data, right? Which is, do we need theory when we look at data to say, okay, this is a hypothesis we're testing, or do we just say, let the numbers speak? A lot of people say, let the numbers speak. All right, that is, I would say, the sort of widespread belief, but there are scientists who know what they're talking about who are saying, hang on, this can lead to problems. Okay, so is big data the future of auditing? I think, based upon the discussion we had, yeah, it will have to be the future of auditing, because otherwise someone like an Amazon or Facebook will come in and eat our lunch, right? Okay, do it instead, but it's like with any other tool, it's only as good as the way it's applied and its results are understood. And we just cannot assume that if big data adds value in business, that will also be useful in auditing, right? Or that auditors will be compelled to use it. And we haven't even talked about litigation risk, all right? Because as the panel talked about, this is a serious concern. I think there was a question on that during the panel discussion, all right? Which is, are auditors more at risk from not doing big data and being held accountable for that, or for doing big data and not doing it properly or as fully as you can, right? I'm not sure which one poses greater risk, and that depends obviously on the litigation environment, which is different in Canada than it would be in the United States. Okay, so finally, the point of this paper is to illustrate that we need to think carefully of big data as a means towards an end of more effective auditing. It is not an end in itself. And sometimes when new technology comes, and I've been guilty of this, it becomes an end in itself. We are so excited by this new technology and its potential that we write papers saying, oh, we must apply it, you be a stupid dinosaur if you don't apply it. But we have to think at some point about how we apply it effectively and well. All right? So anyway, I'll stop there.